Hey guys, this is Miss Schneider, and I'm going to make a couple short videos for the quiz review, kind of one on each type, so you guys can feel a little bit more comfortable if you guys are studying on your own. So I'm going to start here with number 1. Now what we notice is that we have 3 cube roots, so we know we're looking for groups of 3. Now because none of the radicands are the same, I have to reduce each one of them. So if I do 16, we know that's 4 and 4. And subsequently those will break down into 2 and 2. So I'm looking for groups of 3, so I can create one. He's going to go out front with the negative, and I have one single 2 left behind. Now for the cube root of 162, that's a little bit of a larger number. You know 2 is going to go into it. So 2 goes into 2 one time. 2 goes into 16 8 times. So this is going to be 2 times 81. We know 81 becomes 9 times 9, and 9 gives us 3 times 3, and 3 times 3. And again, we're looking for groups of 3s, so there's one group. It's going to come out front, and we already have a 3 out front there. I have a single 3 left behind, as well as a single 2. For 48, we know that's going to be 6 times 8. 6 becomes 3 and 2. 8 becomes 2 and 4, and 2 and 2. So I'm going to make my group of 3 since we have a cube root again, and we know he's going to come out front, but there's already a negative 3 out front. And again, I have another single 3 and another single 2. So far what we have, if we rewrite it, is we have negative 2 cube root of 2 plus 9 cube root of 6 minus 6 cube root of 6. Sorry to run into the other problem there. Alright, I can't do anything with the cube root of 2, but I know I have 2 cube roots of 6, which means those are like terms. So I can reduce 9, or sorry, not reduce, but add 9 cube root of 6 minus 6 cube root of 6. And that's going to give me 3 cube root of 6. So the final answer there, negative 2 cube root of 2 plus 3 cube root of 6. Both radicands are reduced as far as they can go, and we added the like terms. Number 3 is a little different because now we have FOILing, and we have FOILing specifically with radicals. So just remember, any radical times itself is always just the number underneath, the radicand. So we're going to FOIL, and that's my little song, first, outer, inner, last, FOIL, FOIL. So the first terms, we're going to get negative 7 square root of, now 2 times 2 is 4, so that's going to give us 4k. Now the outer terms, so I'm going to get 7 on the outside, square root of 14k. Now the inside terms, minus 7 square root of 14k. And the last terms, and that's going to give me 7 square root of 49k. Now what we're looking for, since the square roots are groups of 2, so again, we can do one of two things. We can reduce each one of these first, or we can add the like terms that we see first. What I see are 2 terms in the center that are going to cross out, since I've got positive 7 14k minus 7 14k. So those are going to eliminate and essentially equal 0, so I can get rid of those. Now what I have here is a 49k and a 4k, which means they're not like terms, but can I make them like terms? I know square root of 4 is 2, and I know square root of 49 is 7, so I'm going to go ahead and pull out those groups, since we know they are perfect squares. So the group of 7s is going to come out, and the groups of 2 are going to come out. What that's going to leave us with is the square root of k, which will be a like term. So I've got negative 14 square root of k plus 49 square root of k. So now all I have to do is 49 and negative 14. Now that the radicands are the same, I now have like terms. So 49 minus 14 is 35. So I have 35 square root of k. Final answer. All right, last type with square roots is to multiply by the conjugate. Now the conjugate is always the opposite sign of the in-between term. So instead of -4 plus square root of 5, I have to multiply it by -4 minus the square root of 5. And what that's going to do is essentially be a difference of squares, which means the middle terms will always cancel. And what I'm also going to do is put all this in parentheses, so that indicates to me that I am multiplying. And what we're going to do here is just FOIL on the top and keep it on the top. Same thing on the bottom, FOIL on the bottom and keep it on the bottom. And usually what will happen is a lot of reducing can take place. Alright, so let's FOIL the top. So 4 times -4, -16. 4 times negative square root of 5 becomes -4 root 5. We have -4 times square root of 5 again, so that becomes -4 root 5 one more time. Now keep in mind, these won't cross out because they have the same sign. Square root of 5 times negative square root of 5 is just negative square root of 25. If you want to go ahead and call that -5, that's fine as well. We know we're going to get there. Now on the bottom, because we're multiplying by the conjugate, we know the middle terms are going to cancel out. So -4 times -4, 16. -4 times negative square root of 5 becomes 4 root 5. -4 times square root of 5, those inner terms, becomes -4 root 5. And here's where they will cancel because they have different signs. And then we have square root of 5 times negative square root of 5, which is negative square root of 25. Again, if you want to go ahead and call that -5, that's where we're headed. So what we have right now, if I simplify what's on the top, we know square root of 25 is 5, and we know -4 square root of 5 minus 4 square root of 5 are like terms that are going to give me -8 square root of 5. So I've got -16 minus 5, which is just -21, minus 8 square root of 5, all over. We know that square root of 25 is also equivalent to 5. So now I have 16 minus 5, which is 11. The last thing we want to check before we know if we're done is make sure there are no terms that can go into each of these three. And the only thing that would go into it is a 1, so we know we're as simplified as possible. When we are rewriting in radical form, this is our power on the top and the root on the bottom. So power over root. So keep in mind when you are multiplying to a variable, it also is the same thing as distributing to that constant. So don't forget to do both. So this is 7 to the 2/3 power and x to the 2/3 power. Since they both have the same root, we know we're going to keep it underneath the same cube root here, power on the top and the root on the bottom. So the cube root of 7 squared x squared. Well, we know 7 squared gives us 49, so the final answer there, cube root of 49x squared. Now what we're looking for are groups of 3. If we tried to reduce this any further, we know we're not going to get a group of 3 out of 49, and we're not going to get a group of 3 out of x squared, so we are done there. When we rewrite each expression in exponential form, again, now we're just going from radicals to the fractional exponent. So this is the power on the top and the root on the bottom. All we do here is take our radicand, and we know the power is 5 and the root is 3. So 10n to the 5/3, final answer. What we would do on something like number 10, there are one of two options. It really depends on the preference of your teacher and the instructions. So if I do power on the top and the root on the bottom, I get 6x to the 4/3, and the 6x is all in a parentheses there. That could be one final answer if all I'm asked to do is rewrite it. Another thing you could be asked to do is not have the rational in the denominator, just depends on your teacher. If you wanted to express this as 6x to the -4/3 and no longer keep it in a fraction, that would be equivalent. Either one of these is appropriate. My guess is your teacher's going to say it's okay to leave it as 1 over 6x all to the 4/3 power.